Hello again, and welcome once more to a video introduction and illustration of IBM's WebSphere Application Server for ZOS Optimized Local Adapters, or WOLA for short. This is the outline for the subjects covered in this 5-part series on WOLA. This is the first of 2 videos in which we'll cover the WOLA APIs used for native programs such as COBOL. The Java programming considerations will be covered in the next section. We have made reference to the native APIs on several occasions in the sections prior to this. They are what provide the structured interface for native programs looking to use WOLA. As mentioned many times earlier, WOLA is part of the WAS ZOS product starting with 7004. It is a mechanism to externalize the local COM function to outside address spaces. The WOLA API modules are shipped in the product file system. A simple shell script is provided that copies those modules out to a pre-allocated module library. You make the module library available to the external address space seeking to use WOLA. This is accomplished with steplib, link list, or in the case of CICS, with dfhrpl. With the WOLA API modules available to the external address space, programs in that address space may now make use of WOLA to access Java assets in WebSphere Application Server. The programming languages supported with WOLA are COBOL, C, C++, High-Level Assembler, or PL1. A common misunderstanding is that the APIs are required in all scenarios. That is not true. They are required in some, but not all use cases. We'll set the stage using a grid, with the type of external address space down the left side and outbound and inbound across the top. As a brief reminder, the concept of inbound and outbound refers to which side initiates the conversation after registration is in place. It is viewed from the perspective of WebSphere Application Server. Outbound from WAS, inbound to WAS. When using batch or USS programs, calls outbound from WAS will require the use of the WOLA APIs in the external program in all cases. The same is true for batch or USS calls inbound to WAS. We saw in the CICS and IMS sections how use of the APIs may be avoided in some cases. That was possible because those subsystems had facilities that allowed shielding the programs. But native batch programs have no such facilities available to them. So writing to the WOLA APIs is required. For calls to CICS outbound from WAS, you may shield your programs from the APIs by using the link server task we described in the CICS section. In reality, the APIs are still in use, but they are a part of the IBM-supplied link server task deep inside that supplied function. The IBM developers who wrote the link server task needed to know how to use the APIs, but programs in CICS do not. As noted earlier, you may bypass the link server task to achieve even greater performance and throughput. Doing so then requires at least one CICS program to make use of the APIs. When calling inbound from CICS to WAS, at least one CICS program must use the APIs. Recall our discussion in the CICS section on how use of the WOLA APIs may be reduced to a single CICS WOLA service program. Other programs then use the CICS direct program link function without requiring knowledge of the WOLA APIs. When calling outbound from WAS to IMS programs using OTMA, the programs in IMS are shielded from the WOLA APIs. Otherwise, for all other outbound calls to IMS require at least some usage of the WOLA APIs. For inbound calls to WAS, at least some usage of the WOLA APIs is required. Please understand, the WOLA APIs are relatively easy to use. What we will now do is establish a few key concepts and then our more detailed review of the APIs and how they are used. We start by offering a categorization of the APIs supplied with WOLA. The Info Center page on the APIs provides a very good detailed reference for all 13 of the APIs. You may access this page by searching for CDAT_OLA APIs. However, that page may leave the newcomer with the impression that all 13 APIs must be used. That is not the case. Again, We set up a quadrant with the columns labeled inbound and outbound and the rows labeled basic and advanced. The term primitive is often used as well. Consider advanced and primitive to mean the same thing for any discussion on the WOLA APIs. The inbound basic APIs are used to call into WAS from the external address space. They are termed basic because they are the most simple to use. But note, to make them simple, the designers of WOLA made assumptions about the behavior of the API. That behavior may be perfectly acceptable to you, and if so, then using the basic APIs makes things very easy. The outbound basic APIs are used when you wish the Java program in WAS to initiate the conversation. Again, basic in that they are relatively simple to use with certain assumptions on behavior made by the IBM developers. The inbound advanced APIs provide the same function as the inbound basic, but they provide you much greater control over the programming behavior. The programming effort is a bit more, as you would expect. Outbound advanced APIs provide the same function as outbound basic, but with greater programming control given to you. With the concept of the inbound-outbound and basic-advanced quadrant in our minds, let's map the 13 APIs to the quadrant. Again, we start with a quadrant. To that, we add another box we'll call both. This is for the register and unregister APIs, which really fall outside the concept of inbound and outbound. Those two APIs are BBO-A1-Reg and BBO-A1-Unreg. We'll take a look at the syntax for BBO-A1-Reg in just a moment. For inbound basic, there is one API, BBO-A1-Invoke. That single API can be used to drive an EJB in WAS over and over again. For inbound advanced, we see 5 APIs. They are BBO-A1 Connection Get, BBO-A1 Send Request, BBO-A1 Receive Message Length, BBO-A1 Get Message, and BBO-A1 Connection Release. The basic API BBO-A1-Invoke does all those things, but with certain assumptions imposed, such as the length of the message back being known in advance, and synchronous program blocking used to keep things simple. The advanced APIs give you access to those finer points of control. For outbound basic, we see 3 APIs, BBO-A1 Host a Service, BBO-A1 Send Response, and BBO-A1 Connection Release. For outbound calls, we must have the native program put itself into a listen state, so it's ready to respond when the Java program sends its message. We can't be certain when the Java program will do that, so the Host a Service function tells the native program to go into a listen state and wait. And yes, the BBO-A1 Connection Release API is used for both inbound and outbound calls. For outbound advanced, the APIs are shown on the chart. We won't spell out each API. The Info Center page speaks at length to what they do. The message here is like what we gave before. The basic APIs are simpler, but with assumptions imposed. The advanced APIs provide greater control, but require a bit more programming. Please don't overlook the Info Center and the CDAT_OLA APIs reference page. It is the definitive source of information on these APIs. And the WP101490 tech doc provides a primer that takes you on a tour through the APIs, from the most basic programming usage up through the most advanced. It comes with downloadable sample programs and step-by-step notes on what's going on at each step. We're going to illustrate the very simplest WOLA program possible, an inbound call using the basic API. We start with a WAS server and a deployed EJB enabled for WOLA. A sample EJB comes with WOLA. Its name is OLA sample1.ear. We bring into the picture a batch program that step-libs to the WOLA module library we mentioned earlier. The batch program uses the BBO-A1-Reg API to create the registration into the WAS server. The BBO-A1-Invoke API is what sends the message into the EJB inside of WAS. This API names the registration to use and it names a service in WAS to invoke. The service name is simply the JNDI name of the deployed EJB. Imagine we wrap a loop structure around the BBO A1 Invoke API. That allows you to invoke the EJB time and time again. The registration stays up the whole time. When the loop processing is completed, the batch program uses the BBO A1 Unregister API to tear down the registration. And the batch program completes.